Okay, Sima. So we are discussing about relation between electric field and drift velocity. Okay, now see. So this is a conductor. In a conductor, we can find free electrons. No? These are the free electrons. So these free electrons, they take energy from atmosphere. Atmosphere also has some energy. No? It is at a temperature of 32, 34 degrees Celsius. So from atmosphere, they take energy. And the electron is a very small particle. No? So, but the energy taken by electron is very large. So therefore, it will be traveling with a very high velocity inside this atom. For example, you have iron benches. No? In iron benches also, these electrons, they will be continuously moving in random motion. Okay, ma? So, but if I apply an electric field, is applied, okay, ma? If I apply electric field, then what happens is, then the electrons continue their random motion, okay, ma? But slowly starts drifting in the direction opposite to electric field. Okay, so what is the meaning of this one? Let us see. So this is a conductor, ma? Clear, no? We are connecting this one to a battery, so plus and minus. So the potential difference applied is V. Length of the conductor is how much? Length of the conductor is L. Then the amount of electric field which is developed inside this conductor, E dash. How much will be its value? E is equals to V divided by L. Already we have studied this one. No? So the potential difference applied divided by length of the conductor will give the field which is developed inside this conductor. Are you able to understand, ma? So now these electrons, how they drift is, okay, see, ma. So when there is no electric field, let us consider this electron has drifted like this. This is in which condition, ma? When there is no electric field. Electric field is not there. So continuously electrons, they are moving in random motion. No? Okay, ma? But if I immediately apply the electric field, then also random motion will continue. Electric field meer apply chesinanta matrana adem straight ga velladu kada. It will continue its random motion. But in the process, what it will does is, it starts drifting towards the, in opposite direction to the direction of electric field. Okay, ma? Just for your understanding, ma. So, it starts drifting like this. Okay. So actually, it should have reached here if there is no electric field. But because there is some electric field, this electron, instead of reaching position A, it has reached position B. Okay. And this distance traveled is called as drift of the electron. Drift of electron. So are you able to understand what is happening? Electric field lekapote. If there is no electric field, electron will reach up to here only. Okay. But because you are applying the electric field is applied in which direction? This is the direction of electric field, no? If this is the direction of electric field, negative charge will experience force in which direction? Opposite direction. So it starts drifting slowly in the direction opposite to the direction of electric field. And this distance traveled by the electron per second, you can call it as drift velocity. Okay, ma? Our distance traveled is called a drift. Drift divided by time taken is called as drift velocity. Are you able to understand? So make a note of it. Okay, ma? So therefore, some mathematical calculations. Very good. Okay, ma? So mathematical calculations also we will do. Force or force experienced by electron in electric field. Okay, ma? In an electric field, how much force it will experience? F is equals to Q into E. This is the formula, no? Do you remember this one? F is equals to Q into E. ఎక్కడి నుంచి వచ్చింది ఈ ఫార్ములా? E is equals to F by Q నోమా. E is equals to F by Q. Force experienced by a test charge, unit test charge in an electric field is nothing but field at that position. So therefore force experienced by electron, what is the formula? Q into E. Q means the charge of electron, no? So instead of this one I can write E into E. What is this E into E? Charge experienced by electron when it is present in an electric field. When you have supplied the battery, field developed, no? And if this is the direction of field, electron will experience a force in opposite direction. And it will experience this much amount of force. Okay? And this is the net force also, no? Is it net force or kada? Chapande. This is the net force also. And what net force will do? F net produces acceleration. Clear, no? Therefore, net force, which is equal to E into E, is equal to mass into acceleration. So therefore, acceleration of electron is how much? E into E divided by mass of electron. So this is the acceleration experienced by the electron. Okay? If there is net force will produce acceleration. And because of this acceleration, electron starts accelerating in opposite direction to the direction of electric field. But it cannot accelerate for a long time. Why? Collisions also will happen, no? Okay, ma? This is the acceleration produced only between this point and this point, or this point and this point. So this is the distance traveled between two collisions, no ma? So in this collision gap only it will accelerate. But once it goes and collides with another atom, it will stop temporarily, or it will change direction. And from there again it will accelerate. Force is acting continuously, no? So even though collisions are present, continuous force is acting on the electron. So continuous acceleration is also produced. But meanwhile, electron will be colliding, stopping, its speed reduces, again speed will increase, again collision happens. So this continues continuously. Are you able to understand? Now, so therefore, we define a term which is called as relaxation time. Okay, ma? What is the time we are studying? Relaxation time. What is meant by relaxation time? Time interval between two collisions. Time interval between two collisions is called relaxation time. Are you able to understand, ma? It is represented by the symbol tau. Okay? For example, one electron is traveling like this, one collision happened, it again moved like this, one more collision happened, it moved like this. Okay? So to travel from point A to B, the time taken is called as tau, relaxation time. Time interval between two collisions. So in this time interval only its velocity will increase, no ma? In this time interval only velocity of electron increases. With how much acceleration? With this much of acceleration. Okay? So therefore, drift velocity, how can I calculate? Drift velocity, Vd. How can I calculate? We can write V is equals to U plus AT, no ma? V is equal to U plus AT. After collision, let us consider velocity of electron will become 0. After collision with an atom, we consider velocity becomes 0. Then how can I write this equation? Drift velocity is equals to 0 plus, what is the acceleration produced? Acceleration produced is E by m multiplied by, and that time interval is called relaxation time, no ma? So multiplied by tau. Okay? So therefore, what is the equation for drift velocity? Equation for drift velocity is Vd is equals to E tau divided by m. This is the equation to calculate drift velocity of an electron. అర్థమవుతుంది కదా? What is meant by drift velocity? The velocity with which electron is slowly drifting in the wire. Why it is drifting? Because of the force it is experiencing. Who is giving that force? Electric field is giving the force. How electric field developed? Because we have supplied a battery. Understood, no ma? That's it. Okay, ma? So this is an important relation, ma? Relation between drift velocity and current. Okay? So relation between drift velocity and current is, this is the relation. I is equals to NEAVD. Okay. Now what is meant by N here? N is called as number density of electrons. Number density of electrons. And what is meant by number density? Number density is nothing but number of electrons per unit volume. Okay, ma? How many electrons are present in a unit volume? That is called as number density. So I is equals to NE. E means charge of an electron. A means area of cross section of this conductor. VD means drift velocity. Okay. So now instead of drift velocity, if I substitute this equation, this is one more equation of current which I got. N is square AE tau divided by M. Understood, no? Very important equations. Sima. So mobility of an electron, which is represented by mu E. So what is meant by mobility? So an electron attains how much velocity? Velocity is nothing but what kind of velocity? Drift velocity, no? So electron obtains how much velocity per how much electric field you are applying. That ratio is called as mobility of an electron. Mobility means movement of an electron. Clear, no? So how much drift velocity it will obtain per how much electric field you are applying. Clear, no? So therefore mu E can also be written as drift velocity divided by applied electric field. Drift velocity formula, or we will do one thing. Here I will write VD is equals to mu E into E. I can write like this. Let it be one equation. Okay. And drift velocity equation, E tau divided by M divided by E. Clear, no? So therefore E and E, if they get cancelled, then E tau divided by M. So this is also an equation to calculate mobility of an electron. E tau by M. Are you able to understand? Similarly, I can substitute the same equation in terms of equation of current also. Now what is the equation of current? I is equals to NEAVD. This is the equation of current, no? And in terms of mobility, this I can substitute here. So take this value and substitute here. Then I can write I is equals to NEA multiplied by mu E into E. So this is one more equation to calculate current. Okay. But here current is represented in terms of what? In terms of mobility of an electron. Is it clear? So questions can be asked on any of these equations. Okokkasari okokka equation paina question is third word. Okay. So all this derivation part you should be clear. After that you have to by heart these equations also. Then whenever question is given, you can identify it is based on which equation and you can solve. Okay. Sima. So next topic which we are studying is current density. Okay. Sima, consider this is a wire whose cross section of the wire is A. This is the cross section. Okay. And how much current is passing through this wire per unit cross section, that is called as current density. Are you able to understand? Current density means what? In an unit cross section, how much current is entering or how much current is leaving that area of cross section in an unit time. Understood, no? So therefore it means that I can write J is equals to the amount of current entering per unit cross section. This is called as current density. Are you able to understand, no? Or statement wise you can write like this. Amount of current per unit cross section. Per unit cross section is called as current density. Okay. So therefore what is the meaning of this one? Sima, here current density is a vector quantity. Current density is what kind of quantity, ma? Is a vector quantity. It is not a scalar quantity, ma. Okay. And here area vector is also a vector quantity, or just you can write area is also a vector quantity. Actually area is a vector quantity or a scalar quantity, ma? Scalar quantity, no, area does not have any direction. But in this condition it is a vector quantity. Why it is a vector quantity? Let us see. See, ma. Cross section. Area means area of cross section only. Okay? Now see. So consider this is a conductor. Okay, ma? and this is the area which I have taken. Then how can I represent area vector, ma? If that is the area of the conductor, what is the direction of area vector? We considered area is a vector quantity, no? So therefore it should have direction also, no? What is the direction? Huh? Perpendicular to? Perpendicular to the surface which we have taken. So therefore this will become my direction of area vector A dash. Understood, no? That is the direction of area vector. Okay. Now what I do is, instead of taking area like this, now see ma, now area of cross section is covering throughout the volume of this conductor, no? Or throughout the area of cross section it is covering, no? So more amount of current will flow definitely. Current is flowing throughout this cross section, no? Current is flowing throughout the cross section. Are you able to understand, ma? This is the strength of current which is flowing. So therefore in this condition how I can write? I can write J is equals to I into J is equals to I divided by A. Or I can write I is equals to J into A. I can write like this. Okay. But what I do is, instead of taking area of cross section like this, if I take area of cross section to be like this. Okay. Now can you say what happens? Area of cross section I am bending by a small angle of theta. Okay. Previously this was the area of cross section, no? Now I want to take this much amount of area of cross section. Now how can I draw the area vector? Area vector now I have to draw like this, no? Now this is the area vector A dash or A1 dash. Are you able to understand what is happening? Now current entering into the new area of cross section, will it increase or decrease? Old area of cross section was this one, indicated by black colored area of cross section. Now this red color area of cross section is the new area of cross section. No? Now current entering into this cross section, will it increase or decrease? Huh? See, into this one, 1, 2, 3, 4 amperes of current was entering, if I consider for example like that. Okay. But in this area of cross section only 1, 2, only 3 amperes of current is entering. No? Area of cross section is same, but amount of current entering has reduced. So automatically current density also will reduce. Arthamatunda emanna? Clear nama? Previously we have taken total area, so total current will flow. Now I have taken only this much area, so very small amount of current will flow. If current reduces, current density also reduces. So therefore what I write? So therefore in new area of cross section, in new area of cross section, what happens? Current reduces. So current density also reduces. Are you able to understand, ma? So therefore how can I calculate the new amount of current, ma? We can calculate like this. So see carefully. Okay. So therefore this is the conductor and this is the area of cross section which I have taken. Clear now? This is the area of cross section A dash, which is making an angle of theta I with respect to current. This is the angle made, no? Previously angle between current and area of cross section was 0, but here there is some angle and that angle is theta. So what I can do is, I will split this area vector into two components now. I can split like this. Clear? So this is A cos theta and this is A sin theta. Now out of these two components, which component I have to take? A cos theta or A sin theta? A cos theta I am supposed to take, because this is the direction of area vector, no, in which current is flowing. So therefore I can write I is equals to J into A cos theta. But previously here what is the value of current? J into A only. But here I am getting J into A cos theta. So when you look at this equation, what do you understand? This is dot product, no? It is in the form of dot product only, no? So I will write I dash is equals to J dash dot A dash. This is how I can write. Are you able to understand? And in differential form, again how I can write, let us see. In differential form, okay ma, I can write I is equals to integration of J dash dot dA dash. I can write like this. Okay? What is meant by differential form? In general form, current is a constant, J is a constant, A is a constant. But differential form means what? Current is a variable. So current density is also a variable. In that condition, definitely you have to apply the integration. I is equal to integration of J dash dot dA dash. Sequence అర్థమవుతుందా ఎలా ప్రొసీడ్ అవుతా ఉన్నామా? While studying also, you should study in the same manner. Okay? Then only you can understand. ఇవన్నీ బుక్స్లో ఏమి ఉండవు. Okay? That's it.